For centuries, humanity has looked up at the cosmos and wondered about our place in it. The idea that Earth is the center of the universe has deep historical and philosophical roots, shaping ancient civilizations' understanding of the cosmos. From the geocentric models of Ptolemy to the religious beliefs that placed humanity at the heart of creation, this notion once seemed undeniable. However, as science progressed, we discovered that Earth is not at the center, not of the solar system, not of the galaxy, and certainly not of the universe. Yet, what if this long-dismissed idea were actually true? What if Earth really was at the cosmic center? How would physics, astronomy, and our entire understanding of reality change? In this exploration, we will dive into the historical belief in geocentrism, examine the scientific revolutions that proved otherwise, and entertain a mind-bending thought experiment. What would the universe look like if Earth were truly its center? The implications stretch far beyond astronomy, touching on physics, philosophy, and the very nature of our existence in the cosmos. Long before the advent of modern science, early civilizations believed that Earth was the unmoving center of the universe. This idea, known as geocentrism, was deeply rooted in human perception and observation. When people looked up at the sky, they saw the sun, moon, stars, and planets moving across the heavens, reinforcing the belief that Earth remained fixed while everything else revolved around it. One of the most influential geocentric models was developed by the Greek philosopher Claudius Ptolemy in the 2nd century AD. His model, known as the Ptolemaic system, proposed that Earth was surrounded by a series of crystal spheres, carrying the planets, the sun, and the stars in perfectly circular orbits. To explain the occasional backward motion, retrograde motion of planets like Mars, Ptolemy introduced the concept of epicycles, small circular orbits within larger orbits. This complex system remained the dominant explanation for the cosmos for over 1,000 years. Beyond Greece, other ancient cultures also embraced geocentrism. In ancient Egypt, Mesopotamia, and China, celestial movements were closely tied to mythology and religion, reinforcing the belief that Earth held a unique and sacred place in the cosmos. The Catholic Church later adopted the Ptolemaic model as part of its doctrine, associating it with divine order. To question geocentrism was to challenge not just science, but religious authority itself. For centuries, this Earth-centered view of the universe remained unchallenged. But as new discoveries emerged and observational tools improved, cracks began to form in the foundation of geocentrism, leading to one of the most revolutionary shifts in human understanding, the heliocentric model. The idea that Earth was the center of the universe was deeply ingrained in human thought for centuries, but as scientific knowledge advanced, this belief began to unravel. The scientific revolution of the 16th and 17th centuries brought forth a dramatic shift in our understanding of the cosmos, led by bold thinkers who dared to challenge the status quo. The first major blow to the geocentric model came from Nicolaus Copernicus, a Polish astronomer who in the early 1500s proposed a radical idea, the heliocentric model. In his groundbreaking work, he argued that the Sun, not Earth, was the true center of the universe, with planets, including Earth, revolving around it. Though revolutionary, Copernicus's model lacked the observational proof needed to convince most scholars. Then came Galileo Galilei, who in the early 1600s used the newly invented telescope to make astonishing discoveries. He observed that Jupiter had moons orbiting around it, proving that not everything revolved around Earth. He also saw that Venus went through phases, just like the Moon, something that could only be explained if Venus orbited the Sun, not Earth. These findings directly contradicted Ptolemy's geocentric system and further supported the heliocentric model. However, his defiance of church doctrine led to his trial and house arrest, showing just how controversial this new vision of the universe was. Adding to this, Johannes Kepler refined the heliocentric model by demonstrating that planets move in elliptical orbits, not perfect circles as previously believed. His laws of planetary motion provided the mathematical foundation for understanding how celestial bodies move. Finally, Isaac Newton delivered the decisive proof in the late 1600s with his theory of universal gravitation, explaining how the sun's gravity governs the motion of planets. With these discoveries, the geocentric model collapsed. Earth was no longer the center of the universe. It was just one planet among many, orbiting an ordinary star in an unimaginably vast cosmos. However, despite all this overwhelming evidence, the question remains, what if, against all logic, Earth really was at the center? What would such a universe look like, and how would the laws of physics have to change to make it possible? If Earth were truly at the center of the universe, the entire structure of reality as we understand it would have to be radically different. The current model of the universe, where space expands in all directions equally and no single point is privileged, would have to be rewritten to make Earth uniquely central. In such a scenario, everything in existence, from the billions of galaxies to the cosmic microwave background radiation, would have to revolve around Earth. The implications of this would be staggering. The sun, moon, planets and stars would need to move in perfect, synchronized orbits around our world, defying the principles of gravity and momentum as we know them. The more distant galaxies, which are currently racing away due to the expansion of the universe, would instead have to revolve around Earth at unimaginable speeds, violating known laws of motion. One of the biggest problems would be the behavior of light and relativity. If we were truly at the center, it would mean that cosmic background radiation, the leftover heat from the Big Bang, would have to be distributed unevenly, reflecting Earth's privileged position. However, the actual cosmic microwave background, CMB, appears nearly uniform in every direction, strongly suggesting there is no true center of the universe. Additionally, in a universe where everything orbits Earth, gravitational forces would have to be fundamentally different. Instead of being dictated by mass, gravity would need to operate in a way that specifically keeps everything bound in circular motion around Earth, contradicting Newton's and Einstein's well-established theories. This means we would need entirely new physics, one where Earth has a unique, unexplained force keeping it central while still allowing galaxies billions of light years away to be influenced by it. In short, a universe with Earth at its center would require the laws of nature to be rewritten. It would not just be a different model of the universe, it would be an entirely different reality, one where physics itself would need to behave in ways we have never observed. The question then becomes, would such a universe even be possible under any scientific theory, or is it purely a philosophical or theological concept? If Earth were truly at the center of the universe, the fundamental laws of physics, as we understand them, would no longer apply. Newtonian mechanics, Einstein's relativity, and even quantum physics would need to be radically altered to accommodate such a universe. First, let's consider gravity. In our current model, gravity works as a force between two objects with mass, pulling them toward each other based on their size and distance. The sun's immense gravity keeps the planets in orbit, and galaxies stay bound together by the gravitational influence of dark matter. However, if everything in the universe revolved around Earth, gravity could no longer function based on mass alone. Instead, a mysterious force would have to exist that keeps everything in motion around our planet. This would contradict both Newton's laws of motion and Einstein's theory of general relativity, which state that objects should move according to gravitational attraction, not arbitrary centrality. Another problem arises with inertia and centrifugal forces. If the universe revolved around Earth, everything beyond our solar system would have to be spinning at unimaginable speeds, generating forces that should completely tear apart galaxies. However, we observe no such catastrophic effects in deep space, further proving that the universe does not revolve around Earth. The only way to make an Earth-centered universe work would be to invent entirely new physics, ones where gravity, relativity, and motion function by different unknown rules. But given that our current understanding of physics successfully predicts everything from planetary orbits to black holes, there is no scientific reason to believe that Earth holds any special central position in the cosmos. The answer lies not in physics, but in philosophy, perception, and the human need to find meaning in the cosmos. The psychological and philosophical appeal of a central Earth. Despite overwhelming scientific evidence against a geocentric universe, the idea that Earth holds a unique or central position still lingers in philosophical, religious, and even psychological discussions. But why? The answer lies in human perception, history, and our innate desire for significance. From a psychological standpoint, humans naturally view themselves as the center of their own experiences. We perceive the world from our own perspective, and before scientific advancements, it made perfect sense to assume that Earth, and by extension humanity, occupied a privileged position in the universe. This egocentric view influenced early civilizations, which saw the cosmos as revolving around them. Even today, many people instinctively feel that human existence must be special, unique, or divinely orchestrated in some way. Religions and philosophies throughout history have often supported the idea of Earth as central to creation, not in a physical sense, but in a spiritual or existential one. The geocentric model was embraced by various faiths, reinforcing the idea that humanity was at the heart of divine creation. While modern science has displaced this notion physically, some still find comfort in the idea that Earth, if not central in space, might still be central in purpose. The idea of a privileged planet has also been explored in modern science. The rare Earth hypothesis, for example, suggests that Earth may be extraordinarily rare in its ability to support intelligent life, even if it is not the center of the universe. This concept allows for a kind of philosophical centrality, where Earth is not physically privileged, but is unique in its ability to foster conscious beings who can observe and question the universe. Another perspective comes from the anthropic principle, which suggests that the universe appears fine-tuned for life because we are here to observe it. This does not mean Earth is the actual center of the universe, but rather that the conditions for life happen to develop in a way that allows us to question our place in the cosmos. Ultimately, while science has shown that Earth is not physically at the center of the universe, the search for meaning and significance continues. Whether through religion, philosophy, or the exploration of life's rarity, humanity still grapples with the age-old question: are we truly special in the grand scheme of the cosmos? While the physical evidence says no, the psychological and philosophical debate remains open, ensuring that the idea of a central Earth, if not in space, then in meaning, will continue to be a topic of discussion for generations to come. Now that we've explored why Earth cannot be the center of the universe, it's important to understand what modern cosmology tells us about the actual structure of the cosmos. Unlike older models that assumed a fixed center, today's best scientific evidence supports the idea that the universe has no central point at all. One of the biggest breakthroughs in our understanding came from Edwin Hubble's discovery of the expanding universe. In the 1920s, Hubble observed that distant galaxies were moving away from us in all directions, and the farther they were, the faster they were receding. This discovery led to the formulation of the Big Bang theory, which suggests that the universe began from a hot, dense state and has been expanding ever since. This expansion does not mean that galaxies are moving away from a single center, rather, space itself is stretching, causing everything to move apart like dots on the surface of an inflating balloon. No matter where you are in the universe, you would observe the same expansion, making it impossible to define a true center. The cosmological principle reinforces this idea, stating that the universe is homogeneous and isotropic. meaning that on a large scale it looks roughly the same in every direction and from every location. If Earth were truly at the center, we would expect to see a different distribution of galaxies or cosmic background radiation when looking in different directions. Instead, observations confirm that no location is privileged, and every point in the universe can be viewed as equally valid. Further evidence comes from the cosmic microwave background, CMB radiation, the faint glow left over from the Big Bang. The CMB is nearly identical in all directions, proving that the early universe had no special point of origin. If Earth were central, the CMB should show significant distortions indicating that everything expanded outward from our location. Instead, it remains consistent, supporting the idea of an evenly expanding cosmos. Moreover, general relativity tells us that space itself can bend and warp due to the presence of mass and energy. However, there is no sign of a gravitational center around which everything in the universe revolves. Instead, galaxies form clusters and superclusters bound together by dark matter and dark energy, but no single point acts as the absolute center of everything. Ultimately, modern physics and astronomy provide a picture of the universe that is dynamic, ever-expanding, and lacking a central point. While Earth may not hold a privileged place in space, the fact that intelligent life has emerged here remains a profound mystery, one that fuels both scientific curiosity and philosophical wonder. In the grand scheme of things, our planet is just one small dot in a vast cosmic ocean. Yet it remains the only place we know of that can ask these questions and search for answers. The idea of Earth being at the center of the universe has long been dismissed by science, yet it still lingers in human thought due to historical, philosophical, and psychological reasons. Modern astronomy, physics, and cosmology have shown that the universe has no absolute center, and Earth holds no special physical position in the cosmos. The expansion of space, the uniformity of the cosmic microwave background, and the principles of relativity all confirm that the universe does not revolve around us. However, while Earth is not at the physical center of the universe, its role as a cradle of intelligent life is undeniably significant. As far as we know, it is the only planet that has developed beings capable of questioning their own existence and exploring the cosmos. While we may not be at the heart of creation, our ability to study and understand the universe gives us a unique and profound place in it. In the end, our importance is not dictated by our position in space, but by our ability to explore, discover, and appreciate the vastness of the universe. The real question is not whether Earth is the center of the universe, but rather, what can we learn from our place within it?